Very low Earth orbit satellites might be the next big thing when it comes to reconnaissance, Earth observation, communications, all the big things that are important to Department of Defense and other defense agencies around the world. So today it was announced that Redwire was awarded a contract with DARPA for their Otter program for what they're calling an orbital drone. That term is unique to Redwire as far as I can tell, but it's a concept that a very low Earth orbit satellite is better for certain applications than a typical LEO, low Earth orbit satellite, or higher. And this is a trend we've been seeing for a while, even like going back to the Cold War, when they used to fly U-2s at very low Earth orbit / very high altitude and take physical pictures with a camera. Like, it's not a new concept, but the applications and the implementation is different. Several years ago, a client hired me to write a report on HAPS, high altitude payload systems or stations, or however you want to say it. And that is the concept that pseudo drones, aerial platforms, or hot air balloons or air stations, that they would be the next big thing, that they would be able to take over a lot of the reconnaissance, communications, Earth observation, remote sensing that we typically see high altitude planes and satellites doing. Have that gap there between where planes typically fly and satellites typically operate. There's this gap here that could be covered. However, in the many years since I wrote that report, there were a lot of problems, and none of those companies have really taken off when it comes to HAPS, high altitude payload systems. It's one of those things where it's so challenging to operate a vehicle or balloon in an atmosphere, in Earth's atmosphere, with its currents and all of that, and keep it in one place for very long. And so the technology has improved, and we have seen some, especially high altitude balloons, those companies that are operating high altitude balloons that are meant to stay in one place generally to provide communications or Earth observation. We have seen improvements there, but generally a lot of those companies trying to operate HAPS or pseudo satellites, they just have gone away, or they haven't made a lot of progress. But what we have seen a lot of progress in is proliferated LEO or LEO constellations, lots of satellites in low Earth orbit, especially when it comes to things like Starlink and other types of satellite constellations that offer communications or Earth observation, remote sensing. And it's natural then that if you've got a bunch of satellites in one plane here and like that big gap, right, that you're going to go lower and lower and lower, as low as you can. So very low Earth orbit, VLEO, I don't know if it's actually called VLEO or not, but VLEO, that is where you do run into difficulties. So this is not without its challenges, because you're really getting more and more into the atmosphere. There's no hard cutoff. So when we talk about where does space begin, where does Earth atmosphere end, it's really all about arbitrary cutoffs in mathematics. So we generally like round numbers as humans. So we generally say the von Karman line is 100 kilometers. The US government uses 50 miles, which is roughly 80 kilometers. Like, it's not a hard cutoff, because there's atmospheric drag even up to the space station and higher. And there's no definition either. So VLEO, I've seen it defined as under 450 kilometers. I've seen it defined as under 400 kilometers. I've seen it defined as 90 to 250 kilometers. There's just definitions all over. One company, Redwire, defined it as under 150 kilometers. So there's no hard cutoff. There's no hard definitions here, but we are talking about going lower than the typical LEO satellite. And what that does for you is it gets you a stronger communications link, because you're closer to the ground, you're closer to ground stations. Energy is not as dissipated, it's the inverse square law, so it's not dissipated as far. The link is just stronger, and there's lower latency. That means there's lower delay in your communications. Same principle of thunder and lightning, right? Thunder and lightning, you're closer to it, you hear the thunder on top of the lightning, because light travels faster than sound. So the farther you get from the thunder and lightning, or the farther you get from that lightning cloud, I should say, the longer the thunder takes to get to your ear. Same thing. That's latency right there. That's delay in the fact that light travels at a certain speed and sound travels slower in Earth's atmosphere, essentially. So that latency benefit is why we see Starlink getting so much success over its competition when it comes to some of the older satellites that have been doing a similar thing, but in much higher orbits, like GEO, MEO. Those higher orbits have a higher latency, a higher delay in communications, whereas Starlink has that lower delay. And a very low Earth orbit satellite will have an even smaller delay. And this can matter. I mean, it doesn't matter in most applications, but it can matter in some applications. You also have the ability to take higher resolution imagery. And that is an area I think that's probably the most important when it comes to going lower into these altitudes. You have the ability, of course, to use planes and drones in our atmosphere, but when it comes to satellites, the closer you are to the ground, again, the higher resolution imagery you can get. You want to get as low as you can so you can get the better resolution imagery that you want to get from the sky without violating someone's airspace. There are, of course, significant problems. You are, again, getting more into the atmosphere. So Redwire is actually developing the SabreSat with an air-breathing engine. Anybody who is operating in that low of an orbit also has to deal with the fact that it's going to be a very temporary situation. You're not going to be as stable in that orbit. The deorbiting process, either you have to continuously burn to boost yourself back up, or you're going to deorbit into the Earth's atmosphere and burn up in Earth's atmosphere within days to weeks, compared to months, years, decades, centuries in higher orbits. So it's not a stable orbit at all because the atmospheric particles are just going to continuously hit you. And speaking of atmospheric particles, oxygen can really corrode a lot of the materials. And it sounds weird, right? We're surrounded by oxygen. That kind of atmospheric oxygen that's that high up there, that actually corrodes materials really quickly. So many issues when operating in VLEO, but I really do think it's an excellent opportunity for temporary orbiting for a specific purpose, for a specific mission. And so it's obvious that DARPA is interested in this. It's obvious that the U.S. Department of Defense is interested in this. And according to Redwire's website, there's a number of European interests that are also interested in VLEO. Tell me whether or not you say VLEO or VLEO, or how else I'm supposed to pronounce that. This is a newer area. We should see more trends in this direction as we're seeing these satellites go from GEO, MEO. I mean, there's still a purpose, absolutely a purpose for those higher altitudes, but we are seeing that trend towards we are seeing that trend from higher atmosphere, from higher orbits to lower orbits. Of course, we're also seeing the trend in the other direction of cislunar space and XGO, and however you want to call it, deep space surveillance and awareness. So we are seeing trends in both directions, but mostly people who are funding these operations are most interested in looking back at Earth. So they're mostly going to be interested in looking downwards back at us.